Hi guys, welcome. In this video, we're going to be creating this mount assembly here for my benchtop power supply. As you can see, we have two components here that we have to create and that we have to work with in this assembly. There's a bracket component and there is a screw component. We're going to go over some elements and features within Onshape that allowed us to actually create this assembly, including leveraging configurations within Onshape to create a right and a left version of this. We'll also be going through how we use Derive, Transform, and Boolean features within Onshape to pull this screw model from a separate part studio, using it not just as a primary screw for this assembly, but also using that screw as a tool to create a perfectly matched integrated thread profile directly into the bracket, essentially giving us a functional internal nut that's custom fit to the bracket with zero manual calculation or thread modeling. So guys, join me. Let's jump into it. Don't forget to like and subscribe. All right, guys, let's get into this modeling. We'll be creating a mount assembly for this Olsen power supply here. I don't really know much about it other than the fact that I got it for free as part of my redundancy. And looking at the price, geez, £174. I guess I scored something. So the first thing we're going to be doing here is just creating a sketch for the general profile for the power supply. So it's kind of this trapezoid triangular shape. So I did some measurements on it earlier. So I'm just going to start by setting up that sketch now. So as I was mentioned, always draw around the origin because that just makes your job just a tiny bit easier. So right now, because I drew around the origin, I could just dimension that overall length, and that line is constrained, and that's dimension to be 95. The kind of the bottom length and the side length are the same here. So that horizontal line is also 95, and kind of the two wedged lines at the top or on the side are both 15 mil based on my measurement. So because I'm using that length in multiple places here, I'm just going to create a variable for it. So name that 95, and then what I'll be doing here is I'll just be replacing that variable in the sketch. I'm going to use an equal sign here. Actually, I could have used an equal sign here for those two lines, but replacing that with a variable is just good enough. So I am using an equal sign here. So I've selected that top line and the side line and use an equal constraint there. So if I label that 15, both lines automatically will change. So that's kind of the general side profile of that power supply, as you can see from the picture. So now I'm just going to create a slight offset around it. So think of this as the final distance between the profile of the power supply and the kind of the inner wall of the bracket. You'll see as this this design evolves. I will say though, this 0.3 mil clearance turned out to be way too small, just because when you actually send this to the printer, there are kind of shrinkages associated with it, so that might vary. I ended up using about 3 millimeters in clearance there, so just keep that in mind. I've also created a wall thickness variable here because I'll be using that at various times in this modeling, especially given the fact that we're creating multiple parts in this model. So it's always a good idea to just set that. So that's now set to the overall thickness to 3 mil. So what I'm doing now is that the table I'm putting this onto is got like some sort of bezel edge profile. So I will just start by creating that and then creating the bottom profile of the bracket around it. So that's what I'm doing right here. I'm just going to quickly set up the sketch for that. It's going to be a construction line anyways, because it's just there as a guide, as a reference, so that I can model around it. So all of these dimensions here might not mean anything to you, but those are the dimensions I took just to actually, while I was trying to measure, that side bezel edge profile. So if you're following this along, just, follow what I'm doing. Don't pay too much attention to what these dimensions mean. So now that's just been created now. I'm going to add a few more lines here, and then you will see the general profile of the edge of the table that I bought. Ideally, I'll probably prefer like a flat edge, but it is what it is. Beggars can be choosers. I also got that secondhand from this Facebook Marketplace. So, it is what I've got. So I'm just going to design around it. So I'm going to add a few more lines here just to create that edge profile. This is always a good idea to do, because sometimes, as you see, I'll point that out as the model progresses, that it's always just having that reference just makes your life a bit easier sometimes, because you have like a visual guide as to what you're creating, and it kind of prevents you from making mistakes. And it's particularly important, especially given how big this part is going to be. When you're sending it for print, you want to, avoid areas where you can make mistakes as much as possible. So that's why this is there. So this is just finished being created now. I'm going to do a vertical constraint on there, so those lines end up in the same place. And then I will complete that sketch. Fun challenge for the viewers of this video, if you can set up this sketch with fewer dimensions, let me know, put a comment, and I'm sure I will get back to you. So the next thing we're doing now is just now setting up the edge, the profile of the lower part of the bracket. So that's going to be at a 1 mil offset from the profile of the table. That's going to be pretty consistent, and I don't think that will matter too much, because it's going to be like a screw that goes on the title, and that's too much. So what I've just done there is just created that offset, and now I'm going to use the previous sketch that I did for the bezel edge profile to create the profile for the lower part of the bracket. So I'm just going to give that a bracket offset there of 1 mil, which I've created also as a variable. And then I'm going to complete this sketch here. The last part I'm going to do is kind of towards the left edge of this, which is to not make that go all the way to the table, to the kind of base of the table, because remember earlier in the introduction, there's a screw part to this model. So this straight horizontal line that I've drawn here is where the screw thread is going to sit. That's why it's not going all the way to the top of the video. And there's probably about 10 mil clearance there, which is just good enough. So that sketch is now completed now. So we're now going to just extrude firstly the top part of the bracket. So this is the part that sits around the power supply, and the bottom part goes over the edge of the table, right? And then the screw kind of tightens it all together. So the first part there is extruded, and now I'm going to move on to creating the extrude for the bottom part of the bracket. So I'm going to use the thin feature here, which is what you use to actually extrude lines when your sketches are not complete. And then I'm just going to select that outer profile over there, all of the lines, and then see where I said it's actually beneficial to actually have a sketch here. I could have made a massive mistake right here, but you see as it goes along. So first I'm going to set that to symmetric, make the width slightly bigger than the top part of the bracket, and then I will spot an issue here. So you see the current profile is not going around the dotted line sketch that I created. It's kind of, we're designing into it, right? Not around it. So I'm just going to reverse that now. So now you see that that's actually now gone around the profile that we created, which is exactly what we want. That's also why you want to be creating a profile like that just for reference only. So the next thing I'm going to do now is just put a thickness around that, which is equivalent to the wall thickness of the overall model plus 1 mil, or the offset of the bracket, so that all of this is level. So as you can see now, I will fling it around. You see that's all level, but I actually don't want this to be one part yet. So I'm just going to change the options in Onshape and make that new. So those are two separate parts of this assembly. We will join them later. But yeah, so now that's created. So just to kind of give a reminder of what we're creating here, there's a screw part and there's a bracket part to this. So now what we're going to do now is actually start modeling parts for this thread part of the bracket. So we start with a 12 mil circle here, just as a gauge. Again, if you're following this, you understand why we chose this dimension later. I didn't dimension around the origin here on purpose because I just wanted more flexibility in terms of moving the circle around. And I'm going to just dimension that from the edge there. And for some reason, this circle got smaller, but you know, it doesn't really matter to me anyways. The sketch is going to be fully constrained. And then I've specified that to be 12.7 mil diameter, equivalent to kind of the minor diameter of the screw that we're going to use. But this is just here for gauging, so I can gauge the outer diameter of the screw boss to give me the right wall thickness. So I've also used, as you can see there, I've used the 3.5 mil wall thickness variable that I created earlier. In that, as I mentioned, when you're using this in different models or in different parts of your model, it's better to just create a variable, so it just makes it easier to edit. So now we're going to extrude that out, but we're just going to extrude that as a solid boss for now. Now we're going to start creating the screw threads for this bracket. As I mentioned in the intro, we're going to be using a screw component from a separate part studio, and we're going to be using that as a tool to actually create the thread profile in this bracket. However, before we can proceed to doing that, we need to bring in that screw model from its respective part studio into the part studio for our bracket. So what I'm doing now is that I'm going to go into the document that contains the screw model that we need. And the first thing I'm going to do is to create a configuration for the bracket, because ideally I want the screw to actually be smaller than the current baseline that we have here. So to do that, I'm going to add a new configuration input, and I'm going to name that major diameter because that's the variable we want to be configuring here. So I'm just going to create 3 configurations for that. The current default, which is 3/4 inches, and I'll create 2 more for 0.6 inches and 0.5 inches. So once that's done, and I will then select the property I want to configure in my variable table, which is the major diameter variable there, and then I will just put in the parameters for that, so 0.6 inches and 0.5 inches. You can use decimals or fractions. Onshape doesn't really care as long as you're specifying it's in inches. The next step here is the most important step, because otherwise none of this will work. We will not be able to use this model within the part studio for the bracket. And that step is to create a version of this document. So versioning essentially tells Onshape what state of the document that we actually want to bring into the other model. So to do this, we're going to click on the create version button there, and then we'll just give that version a name. It doesn't really matter what you put in, anything will do. And that just tells Onshape that we're bringing in version 4 of the screw model. But I realized there that I wanted to add one more configuration for the thread length, which I wanted something between 1 and 2 inches. So I'm just going to create that now. But because I created that after the versioning, I need to reversion that once it is created. So we're going to go up to version 6 now, or version 5 of this model. And that's what we're going to be bringing into Onshape. So now that's done, we're going to go back into the bracket model and bring in the screw model. To do that, we're going to be using the derived feature within Onshape, and I've just clicked the button there, and I'm just going to navigate through the file system in Onshape to bring in that document. So I'm going to select the Part Studio that I want. I'm going to go into Recent. As you can see, the version that we created is highlighted in the latest version. We'll go into the Part Studios within that document, and we're going to go into the second one that has all of the configurations set. So we're now just going to create the configuration that we need for that. So I want fine pitch on that, so 70 ppi, the major diameter, and then we'll just click generate. We select the part, and then that will bring the part into the Part Studio for the bracket. The next step will be to position this within the bracket, and we'll be using the transform feature to do that. We'll be using the transform feature a lot actually. So I'm just clicking into that now, and I want to transform by mate connector. So I've put a mate connector on the edge, and I've put one on the screw bus, and that should immediately move that once I selected it to the bottom of it. But as you can see, the orientation here is wrong. That needs to be flipped 180 degrees, and I'm going to do that now by rotating that part, and I'm going to select rotating about x-axis, and that should flip that around. There's still a few more things we need to do here. It's still not quite right. I need just the threads to be sitting in the bus, so I'll move that whole part down by about 20 mil so that only the screw thread is sitting in the bus. And with that done, I can click out of the transform. So next, we're going to create the O for the thread. I could have actually just Boolean this out and just use that screw to cut this out, but I'm doing this because I want to create a leading for my threads. Whenever you're doing threads in any CAD model, you need to always have a plan for a leading. Otherwise, you know, it's a difficult thing to correct once the thread has been placed, as you can see in some of my previous model. So what I will be doing here is just creating the O equivalent to just about the minor diameter of this using a mate connector. But I'm only doing that so that I can create the leading chamfer for this. So a little pro tip here: you should always have a plan for your leading. I'm going to select up to next here, so it's only cutting up to that phase, and I'm going to click out of that. The next thing I'm going to do now is to add chamfers on this, particularly on the edge that we're going to be screwing onto, right? I'm going to put a nice big chamfer onto that. And now that that's done, we are ready to actually make the threads on the bracket. Before we proceed to making the threads, we need to talk about the interfaces between the screw and the nut. We need to take steps to ensure that we have sufficient clearances in areas where I'm circling red on my screen here. So those are the primary places where the screws meet, right? So if you don't have sufficient clearances in those areas, right, you might run into issues actually trying to use this part. You might find that your screw is binding, or you can't actually get the screw in the nut. So we need to take steps to actually ensure that that doesn't happen, especially considering that we're not using some sort of precision machining means to make this, right? There's likely to be shrinkages and expansions with the way we print, and whatever plan you have for this, you know, it's down to however method you want to actually employ in making this and what you intend to use this for. You know, if you're using this as a sort of precision linear mechanism, probably don't do what I'm about to do, but because we're 3D printing this and I'm not really bothered about backlash, I'm going to take some additional steps to ensure clearances in these areas. So the first thing I'm going to do is I'm just going to copy the screw in place, and I'll go back into the transform window to actually do that. So we'll select copy in place here, and then we'll select the entity that we want to copy, which is our current screw model. So I will click copy in place, and then you see it create an additional part in the parts window over there. So there's another part one in there. So now that that's done, we're going to hide the previous part, And I'm just going to scale this part up uniformly. And because we're swelling up, the scale factor here needs to be more than 1, with 1 essentially representing 100%. So 1.10 here or 1.05 here represents a 5% expansion uniformly across the screw. And you want to make sure that you're selecting the right point here. So I'm actually just going to change this to 1.02, which is 2%, but I will change this to do this by mate connector. You can kind of already see the effect here of what the new part will look like. So I will select the center point in the model there to scale around. And then the number that ended up working for me here that required the least part was actually 1.07. So I'm going to put a B-roll in here now to actually show you me trying that out. But that might vary depending on your printing situation or your printing scenarios. So 1.07 or 7% worked well for me here. So this is me trying out a bunch of parts here. And as I mentioned, 1.07 or 7% required the least amount of work for me anyways. But I reckon you probably go up to about 10% here and you still get good grip between the nut and the screw. Because these are square threads, there's still an element of grinding and removing a lot of balls that you have to do regardless. We can now finally move on to actually creating these threads. I know there's a lot of steps here, but comparing to actually model the threads, sweeping it, making sure they both match, this is actually kind of a cakewalk. So now we're going to use the Boolean feature in Onshape to actually subtract the swollen version of the screw from the bracket. So we'll click subtract there, the tool being the screw and the target being the bracket, lower part of the bracket. And we left keep tool unchecked there because we actually want that tool to disappear. So now we've now formed a perfectly matched thread to the bracket that we can pretty much guarantee will work with very minimal effort. So next thing I'll show you now is I'm going to do a quick cross section on there so you can actually see what we've achieved. So you can actually now see clearances across all of the diameters, so the edges are not clashing. On the kind of shanks, it's just due to the arrangement of this, and because this is not in assembly, I can't really place that screw properly, but I can guarantee you have clearances across the sides where you need them to be. So I'm just going to add a quick chamfer to the top here, which is strictly not necessary, but it looks good. And with that, we are done creating the threads for this. The next thing, the last part of this to complete the model is to actually create a left and a right version of this. So the first thing I'll do here is to just create a sketch using the project feature in Onshape. I will just create a sketch around the edges where I want the shoulder to be. I think here I could have actually selected the shoulder directly, but we'll find out in another video. So once that's done, I'm now going to click on the thin feature within Extrude to actually create the profile there. I need to give this a wall thickness, which is equivalent to the wall thickness. So I will just call in my wall thickness variable here, which is wall_thickness, which will then make that the same wall thickness as the rest of the parts of the part. And I'm going to set the right diameter. So I'm going to set the right length for this, which is, I believe, is about 3 mil. So I think that will be sufficient, as this is the part that will actually be sitting against the edge of the power supply itself. Now that that's done, I need to then create the left version of this on the left side of the bracket. But remember, we actually don't want both of these features to exist at the same time, because otherwise, if we print it out with both the left and the right shoulder, we will not be able to use the part. So we're going to be using configurations to actually suppress the left side or one side while the other side remains. So I've just finished creating the shoulder now on the left side, so I'll set that length equal to the right one, and then we'll go into the configurations window to actually set up the configurations for this. To set up the configurations, it might be worth actually renaming these two features here, right and left, so that you can keep track of it. But in the configuration window here, we'll click add configuration input, and then we'll name the two configurations right and left that we want here. And then for what we're actually configuring, we'll click the unsuppressed state or suppressed state of those features. So that's what I just clicked there, and I'll do the same thing on the left one. So now what we're telling Onshape to do is that if we select the right configuration, suppress the left side. So you will see me complete that now. So I've just renamed it so I can know which one's which. And then I'm going to go into the configuration window and just tick that. So for example, here on the right, if I want the right, I will untick the unsuppressed state of the left shoulder, which is what I'm doing here. And I will do vice versa for the left one. So now if I go into the configuration window and I click the left, only the left one will show and the right one will be suppressed. So this is how this works. So this is how I'm able to actually have a left and a right version of this within the same Part Studio. And with this, we are pretty much now done. And this is ready to be sent off for printing. So thank you guys very much for joining me in this video, and catch you on the next one. Don't forget to like and subscribe to the channel. See you soon. Bye.